double integral over d UVP minus, yes, there is a minus of VV, so it is this is a negative sign, this is plus, and this is along, yes, minus. So UVP equals, what is UVP? It is double integral over d V into L of u minus u into m of v dx dy plus uv along q plus integral v to q u into vv minus u dx. Okay, vv minus vx, not u, vv minus vx dx. So UVP equals double integral over d v L of u minus u m of v dx dy plus UVQ plus integral along PQ u into VV minus VX dx. Agreed. Then, therefore, plus, what remains there? Plus along integral Q to R. The next term, plus along integral Q to R. What remains there? Along Q to R. So, u dy minus v dx dx. Integral u dy minus v dx. U dy minus v dx into dx. What remains? Plus integral over integral along R to P. It is u dv. Okay. From here, this is also, these two terms are also introduced here. Agreed. Okay. That equation converted into that one. So that means the equals, which is equals double integral over d v L of u minus u m of v dx dy plus UVQ plus integral over P to Q u VV minus VX dx minus integral Q to R u dy minus V dx minus integral R to P u into AV minus BY dy. Why? Because what is u? U is that one, AVU minus UVY. That is u. U equals AVU minus UVY. Then you can replace that arguments there. Okay. Now we choose a function. After that, we choose a function Vxy alpha beta. So this function is said to be a Riemann's function. We can choose a function Vxy alpha beta. Then this function is said to be a Riemann function such that the adjoint equation, what is adjoint? M is said to be the adjoint of L, adjoint of L or adjoint operator of L. Then this Riemann's function v of xy alpha beta, then which satisfies the Riemann's equation m of v equals 0. What is m of v? We know that the Riemann's equation m of v is nothing but vxy minus av of x minus bv of y plus cv. Then to consider this vxy alpha beta, which satisfies the equation m of v equals 0. What is m of v? M of v, that is the adjoint equation. M of v is vxy minus aux minus bvy plus cv. So this vxy alpha beta, which satisfies this equation, adjoint equation, m of v equals 0. Then also which satisfies vx, equals bv at y equals beta. Vx equals bv at y equals beta, and vy equals av at x equals alpha, and v equals 1 at x equals alpha and y equals beta. Means you may introduce or consider this function vxy alpha beta, which satisfies the adjoint equation m of v equals 0, where m of v is nothing but vxy minus av of x minus bv of y plus cv, which satisfies these conditions vx equals vy at y equals beta, vy equals av at x equals alpha, and v equals 1 at x equals alpha and y equals beta. Okay. Therefore, this equation, that reduces to uv here at p. What is p? P be the point ordered by alpha beta. P be the point has coordinates ordered by alpha beta. That is the characteristic. Therefore, at alpha beta v equals 1. At x equals alpha, y equals beta, v equals 1. So this reduces to up. Up equals double integral over d v. Then this equation reduces to, after using these conditions and introducing this Riemann function, then this reduces to up equals double integral over d. It is v into L of u minus m of a dx dy. That's a function in f. So it is f dx dy. Double integral over d f dx dy plus what remains uvq, this one, plus uvq minus integral q to r minus integral q to r u dy minus v dx minus integral q to r u dy minus v dx. Why? Because at we know that what is vx? Vx equals vy and vy equals, we know that of the conditions, vx equals bv, vx equals bv and vy equals av. At y equals beta and at x equals alpha respectively. So when vx equals bv, this integrand reduces to 0, and when vy equals av, then vy equals av, then this integral r to p u dy again goes to 0 itself. What remains here? up equals double integral over d vf dx dy plus uvq minus integral q to r u dy minus v dx. Okay. So that's again it equals double integral over d v into f dx dy plus uvq uv at q minus integral q to r. What is u? U means avu minus u vy dy minus v dx. What is v? b vu plus v ux dy. Okay. Then again you can rearrange this one. Then finally it is integral, uv at qr is uvr minus uvq. Consider this uv along qr. uv along qr is nothing but uvr minus uvq. So from there you can find out this uvq. Then after rearranging you have up equals half of something. That is involving all of this function. So this is the Green's theorem. Agree?